So for number 5, this is really calculating infinite limits, right? We had talked about this already. So how are we going to see that we have an infinite limit? Well, the first thing I'm going to do is I'm going to plug in a 1 in. So I'm going to get 1 minus 3 over 1 minus 1. That's going to give me negative 2 over 0. So this tells me I have an infinite limit. In all the other ones, I had 0 over 0. That's why it's not an infinite limit. But because this numerator is not equal to 0, but the denominator is, I have this infinite limit. I also want to mention that we're going to be looking at coming from the negative side of 1. Okay. So here is how I would solve this problem. What I would do is I would first factor this guy. So I'll have an x minus 3. The denominator is going to be x times x minus 1. And then I'm going to look at the signs of the factors as x approaches 1 from the negative side. So in your imagination, you're plugging in numbers like x equal to 0.9999, right? You're plugging in numbers that are getting really close to 1, but you're coming from the negative side. So when I look at this, what's the sign of the numerator? Well, I think the sign of the numerator should be negative, because really it's going to negative 2, which is a negative number. Let's look at the sign of the two factors in the bottom. The sign of the x factor, that's going to be positive, because I'm approaching 1 is positive number. This is a positive number. So it's positive. If I took 0.999 minus 1, is that going to be a positive or a negative number? Is this positive or negative?
Negative.
Negative. So when I look at this, you guys know that a negative divided by a negative is going to give you a positive number. So the net result is going to be a positive number, right? So this guy is the same thing as negative over negative, which is the same thing as a positive. So since this is a one-sided limit, this means that my answer is going to be positive infinity. I know that it's some sort of an infinity if it's one-sided. I just need to know, does it go like this? Or does it go like this? And by looking at the signs, I can tell it goes like that. Does that make sense to everybody? All right. Let's check. So this is the classwork that we had skipped last time, but try number 7. Let's do this one on the left first. So I guess the first thing that, I don't know if you guys realize this, but you have to actually split this into 2. You don't have to, but it's smart to. So I'm going to do that. So we're going to get the limit as x goes to 5 from the negative side of x minus 6 cubed over x minus 5 squared. Technically, you don't have to split this one, but I don't know if you know that already. So let me just split it in case. We got to come from the positive side of x minus 6 cubed over x minus 5 squared. So maybe I spoke too soon. Like the first thing we need to do is we should actually try the direct substitution property. So when I plug a 5 in over here, I'm going to get a negative 1 cubed, which is negative 1. And when I plug in a 5 in the denominator, I'm going to get a 0. So getting a non-zero number over 0, that means you have an infinite limit, in case you didn't realize that originally. And just as a quick reminder, when we have the infinite limit situation, I need to know which one of these four cases I'm in. So from what I'm gathering, you guys are saying we're in this case right here. You're probably right, but I'm trying to justify why do I need to come from both sides? Because I need to see which one of these four cases we're in. Okay. So what happens when I'm looking at this left guy, I'm plugging in numbers like x equal to 4.999. When I come to this right side, I'm plugging in numbers like x equal to 5.001. Just in your head, you're imagining that to figure out what the sign is going to be. So for the guy on the left, this is going to be a negative number, right? It's really -1 cubed over this bottom guy is going to be a negative number squared. So when you simplify this, the numerator is negative and the denominator is positive. So you come from the left, you're going to get negative infinity. Okay. What about for the second one? For the second one, you're going to get -1 cubed again for the numerator. For the denominator, you're going to get a positive number squared. Well, the square of a positive number is still positive, so you're going to get a negative divided by a positive. So you're going to get negative infinity for that second guy as well. So that's exactly that situation where from both sides you're going to negative infinity. So this means that your answer is negative infinity. So this guy is equal to negative infinity. Is there any questions about the one on the left? Did you guys get a chance to try the one on the right yet, or do you want some time to do that? Anyone want some time to work on this one? Yes, please. Okay. Any questions about this one? No.
So you know how, because what I did to get this one, I just plugged it in pretty much, and I got negative infinity. If it works like that, would that like be the answer, or do you recommend that we always check like this?
I think you should always check. I think the one on the right works a little bit differently. So if you try this one, maybe it makes it more obvious why you need to check. But it's really trying to identify which of those four cases we have. Which of these four. And you can't tell which one until you come from both sides. So I'm giving you 3 minutes to try this one on the right here. All right, everyone. So why don't you type your answer in the chat box for the thing on the right? I'll count it down. Ready? 3, 2, 1, go. All right. Oh, a couple of details. So I'm guessing the answer is does not exist. Just taking a look here. And let's check it out. All right. So we should always kind of try the direct substitution first. In this case, you're going to get -1 squared, which is 1 over 0 cubed, which is 0. So we're going to have an infinite limit, right? I mean, you probably figured that already, but you should probably check, you know, on your quiz or whatever, just to make sure you're doing the right type of problem. We're going to take two one-sided limits. We're going to go the limit as x goes to 5 from the negative side. X minus 6 cubed, squared, sorry, over x minus 5 cubed. And then we're going to take the other one-side limit as x goes to 5 from the positive side, x minus 6 squared over x minus 5 cubed. So what numbers are we plugging in? From the negative side, you're imagining it's like 4.999. And from the positive side, it's like x equal to 5.001, for example. And let's see what we get here. So when you look at the numerator, we're going to get -1 squared divided by a negative number cubed. So the numerator is going to be positive and the denominator is going to be negative. So that's going to give you a negative infinity for the one on the left. Does that make sense to you guys? Like Mila, does this make sense to you why it's negative infinity and not positive infinity?
Yeah, yes.
Okay, good, perfect. And then we want to do the same thing on the right-hand side. So you're still going to get a -1 squared over, this time it's going to be a positive number cubed, because 5.001 minus 5 is a positive number. So then this is going to give you a positive over a positive. So this gives you positive infinity. So you get two different numbers. So for this first one on the left here, this was, oops, on the left here, this was both going to negative infinity as you're at 5. But here you're going like this, you're going to negative infinity in one direction and positive infinity in the other direction. So the net result is that this guy does not exist. Okay. Does that make sense, everyone? Yeah. Any questions? All right, cool. So like, if this is what you wanted to do on the previous classwork that we kind of skipped over. So we're going to have this squeeze theorem that I discussed in class. When you're using the squeeze theorem, you're really trying to construct an upper bound function and a lower bound function where the function that you care about is in the middle. So as I explained in the video,